Imagine a weapon that moves faster than a sniper's bullet, but is the size of a commercial airliner. It does not need to be invisible to radar, because by the time an enemy locks onto it, the aircraft is already 50 miles past them. This is not science fiction, and it is not a distant dream. It is the urgent, terrified response to a new reality, where American air dominance is disappearing.
Confirming stealth.
You think you know speed?
On both assets.
You have no idea what is coming.
Running evasive countermeasures.
For the last 3
simulation
decades, the U.S. Air Force has relied on a single philosophy to dominate the skies: stealth. But that era is ending. Nations like Russia and China have developed high-frequency radar and integrated air defense systems, which are slowly rendering stealth technology obsolete. The cloak of invisibility is lifting, and the United States has found itself exposed. If an adversary can see a stealth bomber, they can shoot it down. This is the crisis keeping generals awake at night. The solution is not to hide better. The solution is to move so fast that physics itself becomes the weapon. This is the doctrine of hypersonics. Lockheed Martin's Skunk Works has stepped forward with a solution. They call it the SR-72, or the son of Blackbird. The promise is staggering: an aircraft capable of reaching Mach 6. At that velocity, it could fly from New York to London in under 1 hour. It could strike any target on the surface of the Earth in less than 2 hours. However, building this machine is widely considered an engineering impossibility.
Mach 3.
The heat generated at Mach 6 melts titanium. The engine required essentially does not exist. The challenge is not just aerodynamic. It is
signature on the Darkstar is peaking at the forward stabilizers.
Acknowledged. Monitor for structural integrity.
Command, the drone deployment simulation failed again.
To understand the
Reroute diagnostics
SR-72,
immediately.
we must first understand the giant upon whose shoulders it stands, the SR-71 Blackbird. When the SR-71 was introduced in the 1960s, it was an alien technology. It was capable of flying at Mach 3.2. Faster than a rifle bullet, at the very edge of space. Its primary defense was speed. When a surface-to-air missile was launched, the standard operating procedure was simply to accelerate. The plane would simply outrun the explosion. However, the SR-71 was retired in the late 1990s. Satellites are predictable. An enemy knows exactly when a satellite will pass overhead. The United States lost the element of surprise. For 20 years, there has been a void in the arsenal. The SR-72 is designed to fill this void, but the requirements have changed. Mach 3 is no longer enough. The transition from the SR-71 to the SR-72 is a complete reimagining. The SR-72 is being designed in a digital environment, utilizing materials that did not exist a decade ago. When you accelerate to Mach 6, the physics of the atmosphere change violently. You enter a realm known to engineers as the thermal thicket. At Mach 6, the aircraft is moving at 4,600 miles per hour. The air molecules are smashed against the leading edges. The friction is so intense that the air around the aircraft turns into plasma. This is the same superheated state found on the sun. The nose and wings of the SR-72 will experience temperatures exceeding 2,000 degrees Fahrenheit. To put this in perspective, aluminum melts at roughly 1,200 degrees Fahrenheit. If you tried to fly a Boeing 747 at Mach 6, it would disintegrate and liquefy in seconds. The heat is not just on the outside. It soaks into the frame, threatening to melt the electronics. The shock waves generated at these speeds are so powerful, it can tear a normal airframe apart. The SR-72 must sustain this punishment for hours. It must cruise inside the fire. The heart of the problem is the engine. Conventional jet engines rely on spinning blades that would melt above Mach 2.5. A traditional jet engine chokes on its own speed. To go faster, you need a ramjet. But to reach Mach 6, you need a scramjet. In a scramjet, airflow remains supersonic. This creates a nightmare for combustion. Igniting fuel in a supersonic airstream, 0.6 S, is compared to lighting a match in a hurricane. The fuel must be mixed and ignited in 0.6 S. It's before the air exits the engine in milliseconds. This creates the propulsion paradox. You need a turbine to take off and a scramjet to go fast. But carrying two engines is too heavy. This is where Skunk Works has likely achieved a breakthrough bordering on magic: the turbine-based combined cycle, or TBCC. Instead of two separate engines, the SR-72 utilizes a hybrid system, merging turbine and scramjet into a single power plant. It is a technological chimera. This transition, known as the mode switch, is the most dangerous phase of the flight. The handoff must be seamless. The scramjet must ignite instantly, taking the load. This capability allows the SR-72 to take off from a standard runway, strike a target, and return to land like a normal airplane. With the engine problem solved, engineers had to return to the issue of heat. The solution is active cooling, and the coolant is the fuel itself. The SR-72 likely utilizes endothermic fuel technology. Before the jet fuel is burned, it is circulated through tiny channels beneath the skin of the aircraft. The fuel absorbs this thermal energy, making it more potent. This is a brilliant loop of efficiency. The dangerous heat is absorbed, cooling the skin, and then that superheated fuel is fed into the scramjet for maximum thrust. Now, we address the guidance problem. The plasma sheath blocks radio waves. This is known as the plasma blackout. For a weapon, a few minutes of blindness is unacceptable. The primary solution is Advanced Inertial Navigation Systems, INS. The second, and more alarming solution, is the development of plasma-penetrating radar or communications. The Wave Rider's ability to maneuver means it can perform a pop-up maneuver, slowing down to look around, acquiring the target, and then diving in at terminal velocity. This search and destroy capability implies a level of autonomous artificial intelligence on board the missile. The primary issue is the geometry of the Earth, the radar horizon. Radars see an ICBM coming from thousands of miles away, giving the defense system 15 to 20 minutes of warning. But the Mach 17 glider is flying much lower, skimming the upper atmosphere. Because of the curvature of the Earth, a ground-based radar might not detect the glider 0.4 sich until it is only 500 miles away. At Mach 17, 500 miles is covered in less than 2 minutes. This gives the Russian operators roughly 100 seconds, 0.6s to classify it, 0.4s calculate a firing solution, 0.4s and hope the interceptor can maneuver fast enough to hit it. It compresses the reaction time from 0.6 from tense but manageable 0.4s to physically impossible. The terrifying reality of Mach 17 is that it doesn't necessarily need a warhead. The formula for kinetic energy is 1/2 mass times velocity squared. Speed is the dominant factor in destruction. A concrete block hitting a bunker at Mach 17, 0.6s, delivers an energy transfer comparable to tons of TNT. This allows for kinetic bombardment. It solves a major political puzzle. It creates a conventional strategic deterrent. It blurs the line between conventional war and nuclear war. The U.S. approach has been plagued by stop-start funding. Programs are started, achieve a milestone, and are then canceled or put on hold. In contrast, China has adopted a slow and steady accumulation of technology. They have built the world's largest hypersonic wind tunnels. The Chinese Scramjet focus is more ambitious. A powered missile creates a flatter, lower trajectory. It flies below the radar horizon, hiding behind the curvature of the Earth until it is too late. The true nightmare of the Wave Rider technology is its ability to change the cost-exchange ratio of war. The Wave Rider design allows for dual-mode capability. It can loiter. It can change its timing. It can synchronize its arrival with other missiles to overwhelm defenses simultaneously. The solution was not to hide in the shadows, but to outrun the light itself. The revelation is that the missile isn't just a weapon. It is a time thief. It steals the minutes necessary for defense, leaving only seconds for regret. The era of hypersonic warfare isn't coming. It is already here, reshaping the geopolitical map at 5 kilometers per second.
Strategic defense system active. Launch sequence initiated. Impact confirmed. The indicators are spiking globally. We're looking at a coordinated escalation.
Beijing's rhetoric is hardening.
Что это? Откуда оно взялось?
Скорость слишком велика, товарищ генерал. Мы теряем его.
They're exceeding the projected velocity. 1 mile per second confirmed. Get me the SecDef now.
Отслеживайте траекторию. Поддерживать максимальную готовность.
Запуск новейшей системы S-500. Ракета успешна.
国际局势器战胜胜局。
The telemetry shows the WU-14 maintaining hypersonic speeds at 60 kilometers.
We are tracking impact probability now, General.
Срочные новости. Вооруженные силы приведены в полную боеготовность.
受需去协同单元。
Срочное сообщение. Ситуация на границе.
收到，收到，听清楚了。
Все ВЛК приведены в боевую готовность. The alert level has been raised to DEFCON 1. All commanders report ready status. We have a confirmed visual on the SR-72, General.
Сводка новостей. Напряжение на границах нарастает. Всеобщая мобилизация.
国际局势进程，边境地区进入紧急状态。
The shadow is moving faster than anticipated over Ukraine.
Confirming hypersonic speeds. Get me Moscow and Beijing immediately.